Although we are going to go ahead and look at a couple things from 121. Again, super important concept of being able to reflect over the line y equals x. So I definitely want to make sure everybody has that down. Again, super important for a graduation test in May. So I know this isn't technically y equals x, but it is a diagonal line. So I know in class we talked about this, but there's a couple different ways that we can go about reflecting this over this particular diagonal line. So one thing that might help is if you go ahead and make points to represent where we are reflecting over the line. So in this case, I can go ahead and put a point there, 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 and there. So we have a couple different ways. Because it's a diagonal line, we can either count diagonally. So what I mean by that is it's a half to the line. So counting through the corners, so it's a half. So we could go another half, and that would put us right there. So the new point that would match up with this one would be the new red one. And then I can take a look at this one. So we would go 1.5. But when I count this, it's just going to be the half first. So half and then 1. So that point is going to have to go there. So that takes care of those 2 points. So that's an option. Or we could, again, make that 90 degree we talked about in class. So I could go left 1. I can't keep going left 1, but I've got to make that 90 degrees. So then we go up 1. So that would put us there. Or again, this one, 1, 2, 3 to the left, make that 90 degree. 1, 2, 3 up. I could also go up and then left. That's perfectly fine. 1, 2, 3, 3 left. So that gives us that one. So then if I look at this, again, if we count diagonal 1.5, half, and then 1. So that is going to put me right here. And then, again, I could count 3 right, make that 90 degree, and go 3 down. And then this one here, 1, 2.5. So half, 1, and 2. So that would put us right here for that particular point. And we could go ahead, probably best to use a straight edge. And we can see we get something that looks like that. And big key is if I'm reflecting something, it needs to be the same size and same shape. It does not change the size of something. So we start out with a 6x2, we end with a 6x2. So the last thing we're going to take a quick look at is going to be 152. So that's on the second page. So we want to make sure we definitely have this. So we're going to reflect this y equals x squared plus 3, which it says is a parabola. So again, I know some classes got through this, but we can go ahead and make a table. So if I make an xy table and fill in those values, so -3, -2, -1, 0, 1, 2, and 3. So we're just plugging in those values into our equation here. And we got -3 through 3 here. So if I plug in -3 squared, -3 times -3, positive 9 plus 3. So this should give us 12. -2, I plug that in, -2 squared is 4, plus 3 is 7. -1 squared, -1 times -1 is positive 1, plus 3 is 4. Plug in 0, we get 3. Plug in 1, we get 4. We plug in 2, 2 squared 4, plus 3 is 7. And if you remember anything from Algebra 1, again, wherever that vertex is, they are symmetric on each side. So then this also here is 12. So I can't graph all of those over here. I can't graph the 12s, but I am able to graph the other two things. So -2, 7. We have -1, 4. We have 0, 3. We have 1, 4. And the last point that we can graph on this graph is 2, 7. So we definitely see that we have a parabola, and it's going to look something like that. So that's what we're going to call a pre-image. That's what we start with. So now I need to reflect over the line y equals x. So now reflect the parabola over the line y equals x. So we want to figure out what that line is going to look like. So that's definitely in slope-intercept form. So our slope is 1/1. And our y-intercept is 0. That was on the algebra review because it is something that is important to make sure we do.
Rugby team will be practicing.
So if I graph that, it's going to look something like that diagonal line. Typically, lines of reflection, we draw them with dashed lines. So when I go ahead and draw this in, we end up with that dashed line. So again, we have a couple different ways, like we counted the rectangle, we can count diagonally through the boxes, or we are able to count and make that 90 degrees. So what I mean by that, I can count to the line down 3. I've got to make a 90 degree, so it's going to go right 3. So that'll put us at 3, 0. Or again, I could count diagonally through the box, so 1 and a half, half, and then 1, and that puts us there. So if I look at this one, 1 and a half, half, and then 1. So our next one would be there. Or we could count right 3. I can't keep going right 3 because it's a diagonal. I would have to go down 3. If I look at this one, we could go down 1, 2, 3, 4, 5. And I would go right 5, 1, 2, 3, 4, 5. So that would put us here. And so on and so on. So right 1, 2, 3, 4, 5. Down 1, 2, 3, 4, 5. And that would put us there. And then same thing, down 1, 2, 3, 4, 5, 6, 7, 8, 9. So make the 90 degree, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would go ahead and put us there. So one of the other questions, it says, what happens to the x and y values? So a couple of the points, if we look at negative 2, 7 was this point up here, so negative 2, 7, and that turned into reflecting it over to this one, which is 7, negative 2. So that turned into 7, negative 2, and then I have negative 1, 4. So this point, if I reflected it, that matches up with this one, which is 4, negative 1. And then 0, 3 turned into 3, 0. So some of us are seeing a pattern here. So one thing that happens if I'm reflecting over the y equals x is just they switch. So negative 2, 7 becomes 7, negative 2. Negative 1, 4 becomes 4, negative 1. So my x and y's are just switching with each other. So that's maybe something worthwhile remembering, especially since there's been something like this on the graduation test the last 4 years, like I mentioned in class. So definitely want to be able to reflect over the line y equals x. Super, super important.